Hello and welcome to the RMIT University and Swinburne University of Technology's entry to the TMS 2024 Bladesmithing competition. Our blade is titled Antipodean iron and is largely made from Australian minerals and materials. The first step in the creation of the knife was smelting the ore. Iron ore was collected from two locations, Lal Lal and Noa Noa, both from the Australian state of Victoria. Ore was crushed up into small pieces before being used for the smelt. The furnaces you can see here were constructed from clay and sugarcane. Every 12 minutes, a kilogram of ore and charcoal is added to the furnace for a 5-hour period. This results in about 300 grams of smelted iron from 21 kilograms of ore. This iron was quite spongy and filled with gaps and therefore needed to be refined. The iron was refined by first hammering the individual pieces to compress the gaps present from smelting. They were then forge welded together, first under a fly press, then under a power hammer to further refine the iron. During all forging processes, it was essential for safety that eye protection as well as long pants and steel-toed boots were worn. Once welded, it was then drawn out into a billet, also under the power hammer. After lab testing, the iron was determined to not be hard enough for a knife, so it was decided to use a sand mine construction. A piece of 1070 steel was sandwiched between the smelted iron. The pieces were then forge welded together under a power hammer until the resulting billet was about 3mm thick. At this point, the knife could be forged. Forging started by establishing the tip of the knife. The knife was then progressively lengthened and widened over several forging heats, ensuring that the temperature of the steel was high enough to not separate the forge welds. After the pre-formed shape of the knife was created, the bevels were forged in, making the knife thinner towards the edge. After this, the tang was created by setting down some material at the edge of the anvil. After forging, the knife was normalised 3 times and then moved on to grinding. Eye protection, a face shield, respirator and earmuffs were all worn during grinding to mitigate safety risks. Grinding started by cleaning up the lines and transitions of the knife. The faces were also ground to remove all fire scale from forging. Hardening was performed in a small gas forge. The knife was heated to around 800 degrees Celsius and held for 5 minutes before being quenched in oil. Afterwards, it was tempered 3 times in an oven at 200 degrees Celsius. The knife was ground again on the belt grinder, refining the bevels to their final dimension. The knife was then hand sanded from 180 grit all the way to 600 grit. After hand sanding, the knife was ready to be etched. The blade was degreased before being placed in ferric chloride acid to bring out the pattern of the smelted iron and sand mine construction. The handle was made from a block of stabilised gidgee, an Australian hardwood. Using a belt sander, the corners of the block were taken off and then smoothed out to create a round profile. To glue the handle of the knife, pieces of a hot glue stick were cut and dropped into a slot that had been cut out for the tang of the knife to fit into. The tang was then heated with a blowtorch before being inserted into the handle. This melts the glue and secures the knife to the handle. Camellia oil was applied to bring out the natural colour of the gidgee, resulting in the finished knife. The team would like to acknowledge the support of Waterside Metal Art for the donation of charcoal for smelting and for the use of their forge and tools. We would like to thank Toby Bockholt of Metal Monkey Knives for advice on forging and heat treating, as well as the donation of gidgee for the handle. Smelting was conducted in tandem with Robbie Allison of Organic Iron Studio. Administrative support was provided by both RMIT University and Swinburne University of Technology. Thank you for watching.